Hello, welcome back. In today's video, we are going to start looking at textures. Nothing too crazy. A texture is just loading in an image. So to start with, we will need a library which can load images. I mean, we could do this by hand, but it is a little too much. So really popular library here is STB Image by Sean Barrett. We can just search for that, bring this up, and we have a bunch of files, of which stbimage.h is in there. So the way we can grab this code is we just pop up here to code, and we can clone it if we want, or we can simply download zip. We click that, it downloads it. Okay, cool. So here in our downloads, I've got STB master, so I will just extract that there. And it is here. This is the header file that I'm after. So this is a header only library. I'll just copy that over to my project. And then I'll also want a folder to store my textures. And if we go back to downloads, I also downloaded a simple wood texture. Put that in. There it is. It's wood. What else would we expect? Okay, so we can close that down. Now I want to get this running. So we will click over to our project and we will add an existing item, and we grab that stbimage.h, and that's in there. So what we need to do is we need to include it. But there's an important issue with this header file. This is a header only library, and if we click in here, it says that we need to call this define STB image implementation before we include the file. So the reason for this is that this is quite a heavy weight package. It's not that much. It's only 8,000 lines of code. That's not too bad. But we want to include this header potentially in a bunch of different files so that a bunch of different places know about the function declarations, but we only want to have the functions defined at one point. Otherwise, it's too heavy on the compiler to be recompiling 8,000 lines of code. So we can include this header file in as many different places as we want, but we have to implement it at just one spot, if that makes sense. Okay, so the next thing we need to do is we need to jump into our shader code and update it a little bit. So we'll go down. Okay, so we're going to send in another bit of input. So this will be in location index 2, and it's a two-dimensional vector, and we're going to call it vertex texture coordinates. Okay, and we're going to also pass that out to the fragment shader. As fragment texture coordinates. Okay, cool. So now, just the same way that we pass the color through without much without any modification, we will do the same thing. So this is take this data, just pass it directly through. Awesome. Okay, now for the fragment shader, we are going to take in those fragment texture coordinates. And we have another thing as well. So we're going to load in a texture, and this is kind of automatically loaded into a type called a uniform. Sorry, not a uniform. Well, it is a uniform. It's loaded into a two-dimensional sampler, and that is applied as a uniform. Now, a uniform is a bit of data which is applied to every object in a scene, like global data. So we have a uniform which is working here. The type is a sampler 2D, and let's call this basic texture. We'll see why. So I want to call it texture, but you'll see why in a second. We can't just call it texture. So let's say we get the color. We also want to sample from our texture, and the function that we use there is called texture. So the first argument is the texture object that we're sampling from, and the second argument is the texture coordinate that we're sampling. Okay, and what we'll do is we'll take those two values, so the color value and the value from the texture, and we'll multiply them in together. So that just colors the texture according to the color, like we've got a colored light on the wood, if that makes sense. Now there's another thing. So by default, when we load images in, they're actually loaded in flipped upside down. I don't know why, it's just what it is. So a way we can get around that is take this and reinterpret it. So we'll take the x coordinate, and then we'll take the y coordinate. But in order to flip it around, we will go 1.0 minus the y coordinate. And this essentially just reverses those values and makes the texture the right way round. Okay, so there we have it. That is working. And I think one way we can test it is we can just run it. Good. We don't get any errors. We do get a black screen. That's because we haven't loaded in any textures. So far, so good. Now let's go down to the program, and we need to pass in another attribute. We need to pass in texture coordinates. So it's common to use S for the horizontal texture coordinate. S goes from 0 to 1, where 0 is all the way on the left, 1 is all the way on the right. And T goes from 0 to 1, where 0 is the bottom of the image and T is the top of the image. Actually, this makes sense because it's common in graphics coordinates to start with 0 at the top of the image and run down. That's why when images are loaded, they are the wrong way around. Okay, so let's have a go at this. So this point here is on the bottom on the left. So we'll go 0 for the S on the bottom, so 0 for the T. And then here we are on the right, on the bottom, so 1 on the bottom, and then we're at the middle at the top, so 0.5 on the horizontal and 1.0. Okay, cool. So vertex count is still 3. Our stride is now 8 because we've got, 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 floats there. Okay. So this is all good. We've got position, color. Now let's put in the texture coordinate. So that is attribute 2. Now attribute 2 has S and T components, so 2 numbers, and it starts 6 floats into the array. So again, we have the X, Y, Z, that's 3, and then the red, green, blue, that's another 3. So our texture coordinates start at an offset of 6 floats. Okay, yep, and then we will, yep, okay, cool. Okay, awesome. So now what we need to do is we need to create our texture. The first thing we're going to do is we'll just tell the shader that this texture has texture unit 0. It's common to pass in a whole stack of textures and allocate them to separate units. So we'll just set this to the first one. So we'll go GL uniform. So we're setting one integer within our uniform, and we'll grab the location. So get uniform location. We say which uniform are we searching? Sorry, which shader are we searching? Our one. What name are we looking for? We're looking for basic texture. And we are setting this to 0. That is allocating texture unit 0 to this texture. This will make more sense later. Okay, so now we'll load the image. So there's a few things we want to know. We want to know the width of the image, height of the image, and the number of channels. Okay, so we call load. We need the file name. The file name is within the textures folder. It's, what is it? wood.jpg. We can just double check that. Refresh that. We've got textures, wood.jpg. Okay, awesome. So then what we need is okay, so we're going to pass in a pointer to text width, and what this does is it loads it and then it stores the width value in there. And same with the height and the channel count. And then the last thing I'm going to do is I'm going to pass this in. So it's very common that we have images and we load them in and we try to use them as RGBA and it just doesn't have that format, or maybe we're loading in something which has an alpha channel but we don't want an alpha channel to be there. So we can actually specify how we want to load this. I'm going to go STBI RGB. So we can go STBI RGB if we just want red, green, blue. I'm going to go RGB alpha. Why not? I'm not actually going to use the alpha channel, but that is fine. What's doing here? Let me just double check that. Right, okay, sorry. So when we load this in, this returns an STB IUC, which stands for unsigned character. So we'll do that. Okay, cool. So now let's create our actual texture. sorry. Okay, so we're going to create textures, and remember we're using DSA, Direct State Access, from OpenGL 4.5, so it goes slightly differently to the traditional way this works. First of all, we pass in what sort of texture we want to create. We're going to create a two-dimensional texture. We're going to create one of them, and we're going to store that result in our texture variable. Okay, so the next thing we need to do is we need to declare the storage which will be used by the texture. So we go GL texture storage 2D, and we pass in the texture, the number of mipmap levels. So a mipmap level is automatically generated to scale an image depending on how close you are. But we are not going to use mipmap levels at this stage, so we'll just pass in 1, which is basically no mipmapping. Okay, internal format. This is GL RGBA, but we have to put in RGBA 8. This is an OpenGL 4.5 thing, otherwise it doesn't work. Width. Text width. Text height. Okay, so that has allocated storage internally, but it has not actually sent the data there. So the next thing we do is we call what's called a sub image. So we go GL texture sub image 2D. Okay, so again, looking through the arguments here, first we have our texture, then we have the level. Well, we're just going to go with the base mipmap level. Again, that's no mipmapping at all. The X offset is going to be 0, Y offset is 0. The width is texture width. The height is texture height. The format, so this is GL RGBA. We don't need the 8 in this case because it's saying what is the format of the thing that the image that we're loading from. That's just RGB. Type, so that is saying what type of data, what data format is being used. So we loaded this in as unsigned characters, and a character is basically a byte of information. So we'll go GL unsigned byte, and then a pointer to the pixels, so we can just pass in data. Okay, cool, awesome. So then we will need to set in some texture parameters. GL texture parameter I. Okay, so this is based on our texture. Okay, so what I'm doing here is I'm saying on the horizontal texture coordinate, if you go out of bounds, simply repeat the texture. And we'll do the same thing for the T wrap. So some other things we could do here is we could clamp. So once we go beyond a certain amount, the texture just becomes all black or whatever. You kind of get the image stretching out because you're sampling beyond the range, but you're just taking the color at the boundary and things like that. Repeat is the simplest for this case. Okay, so then the next thing we will do is we'll do the minifying filter. Now the minifying filter is saying if we're far away and we need to shrink the texture down, then what will we use here? And we will go linear filtering to shrink the image down. And then also, if we're close to the image and we need to blow it up, what filter do we apply there? We'll use GL linear again. Actually, just so you can see, another option is GL nearest, which just samples things. It just crunches the data, which is fine for minifying, shrinking down. If we're magnifying and we use nearest, then it looks really pixelated, which you might be into that. I don't know. Okay, so another thing we can do is we've loaded all of this. We can then free the data that was loaded. So STBI image free data. Let's freed it up. Okay. And of course, we will need to go, just while we remember, down the bottom and delete that texture as well. So we go to delete textures. I'm going to delete one texture. There we have it. Okay, cool. So then the question is, how do we draw? So I'll pop down here. So what do we do? We clear the screen, we clear our buffer, or we declare the clear color, clear the buffer. We set it up with our program, and then I'm going to stick this in here. We bind the texture. Now, again, in OpenGL 3.3 or something like that, anything up to 4.5, it would be, what is it? Set active texture and then bind to, texture 2D. We don't do this. All in one call, we're binding texture unit 0, which is what we declared up above. And to that, we are binding the texture which we loaded. Okay, so let's give it a shot. Let's see what we get. Nice. Okay, so see, we have the triangle, and what we're doing is we are multiplying in the colors with the texture color. Cool. So that was fun. We got that working. Yeah, have fun and see you in the next one.